Hello all, welcome to my YouTube channel. Today we shall do hypothesis testing for two proportion. So we shall do Z test for two proportion. Let us see what is given. Okay, from a sample of 50 residents from city 1, 68% support a certain law, and from a sample of 50 residents from city 2, 56% support a certain law. So we have to test at 1% significance level is there is sufficient evidence to conclude that proportion of residents who support this law is different between the two cities. Okay, that means we have to compare two proportions P1 and P2. These are population proportion for city 1 and city 2. Okay, and what is given? Sample size is given N1 and N2, both are 50-50, and what is given? Sample proportions hat P1 and hat P2. Okay, so these two are given. We can see that 68% is for CT1, that is this is 0.68, this is equal to hat P1, and 0.56 is for hat P2, and sample sizes are 50 and 50. So we shall conduct Z test for two proportion. Okay, we shall start our hypothesis testing step by step. Okay, and we shall do this hypothesis testing in both way, conventional and p-value approach. What is conventional way? Here we find out the value of test statistic and compare this test statistic with the critical value. Okay, and in p-value approach we find out the test statistic and we calculate the p-value and we compare the p-value with the level of significance. Okay, so let us start with the step-by-step approach, and the first step is formulating null and alternative hypothesis. Okay, so null hypothesis denoted by H naught, it is the hypothesis of no difference. So we are comparing two population proportions. So in the null hypothesis we say that these two are not different, P1 equal to P2. Alternative hypothesis comes from the question. Okay, the question is whether there is difference between the proportion in two cities. Okay, so the alternative hypothesis will be P1 not equal to P2. See, it is only mentioned that whether there is a difference. It is not mentioned whether one is less, one is more. That is why we shall only write down the not equal to sign. Since the alternative hypothesis is containing the not equal to sign, this is called two-directional alternative hypothesis, and the test is called two-tailed test. Okay. Step 2 is the calculation of the test statistic. Okay, the test statistic Z is given by hat P1 minus hat P2 divided by square root of P multiplied by 1 minus P multiplied by 1 by N1 plus 1 by N2. Okay, so what is this P? P is called pooled proportion. Okay, the formula for P is N1 P1 plus N2 P2 divided by N1 plus N2. Okay, so we are given with N1 hat P1, N2 hat P2, these are all given. With the help of this we calculate the pooled proportion P. Okay, substituting these values, N1 is 50, hat P1 is 0.68, N2 is again 50, hat P1 is 0.56 divided by 50 plus 50, we get the P as 0.62. Okay. Another way to calculate this pooled proportion P is x1 plus x2 divided by n1 plus n2. Suppose if the question was like that without giving the sample proportion, if it was given that out of 50 people 34 supported the law, and for the second city out of 50 people 28 supported the law, that means N1 and and x1 and x2 are given, then we just use this formula to find out the pool proportion 0.62. Okay. Now we put all the values in the Z statistic formula. Okay. 0.68 is our first sample proportion, 0.56 is the second sample proportion, divided by square root of 0.62 multiplied by 1 minus p, that is 0.38, 1 by 50 plus 1 by 50. After calculation, we get the value of test statistic is to be z equal to 1.24. We keep up to 2 decimal places. Generally, the test statistic values are kept up to 2 decimal places. Step 3 is the decision rule. Okay. Given level of significance to be 1%, that is alpha equal to 0.01, and the critical value of z is for 1% level of significance and 2 tail test, critical value of z is 2.58. Okay. Since the test is 2 tail, that means critical value will be at the both tail of the z curve. Okay. So this is actually the critical region, in the left tail and in the right tail, and in the middle this is acceptance region. So what will be the decision rule? It will be, we reject the null hypothesis if calculated value of test statistic is either less than negative 2.58 or greater than positive 2.58. Okay. In short, we can write it as if mod z is greater than 2.58. Modulus z is greater than 2.58. Step 4 is the decision. Okay. So, our calculated value of test statistic is z equal to 1.24. And what is the critical region? Critical region is z less than negative 2.58 or z greater than positive 2.58. But this z equal to 1.24 lies somewhere here. Okay. So it is not lying in the critical region, it is actually lying in the acceptance region. Okay. Therefore, since modulus value of z is less than 2.58, we fail to reject the null hypothesis. Okay. Why I am writing this modulus z? Because this is a 2-tail test. Okay. The value of z may be negative or it may be positive. So, if we write down modulus sign, then it gives the neutral value. Then we go to the final step. We have failed to reject the null hypothesis that P1 equal to P2. That means we cannot conclude that P1 not equal to P2. Okay. So, there is not sufficient evidence to conclude that proportion of residents who support this law is different between the two cities. So, this is our final conclusion. Now, we shall do the same test using p-value method. In p-value method, step 1 and step 2 are same, that is we formulate the null and alternative hypothesis and then we calculate the value of test statistic. The calculated value of test statistic comes out to be 1. Then we go to step 3, that is calculation of p-value. Okay. So, this is a 2-tail test. So, p-value will be at the both tail of the z curve. Okay. So, our value of test statistic is 1.24. So, p-value will be the area to the right of positive 1.24 and area to the left of negative 1.24. So, these two area gives the p-value. Okay. And the formula for p-value is given by probability of modulus z greater than 1.24. 1.24 is the value of the test statistic. Okay. So, we can break it like this: z less than negative 1.24 plus probability z greater than 1.24. So we find out this probability z less than negative 1.24 from the z table. Okay. From the z table we find out the value negative 1.24, z equal to negative 1.24. See, from the first column of z you can see it is negative 1.2, and from the first row of z we can see 0.04. So we combine these two value, negative 1.2 plus 0.04 gives negative 1.24, and the intersecting cell is 0.10749 or 0.1075. So this is the area to the left of probability z greater than z less than negative 1.24. Okay. So we write down the value 0.1075 plus 0.1075, same value. Why? Because the z curve is a symmetrical curve. So whatever lies in the z, negative z 1.24 will be same as the lies whatever lies to the right of positive 1.24. Okay. Adding these two we get the p value as 0.2150. Then we go to the step 4, that is decision. In p-value method, how we make the decision? We compare the p-value with the level of significance. Okay. Here p-value is 0.2150 and level of significance is 0.01. Clearly we can see that p-value is greater than the level of significance. In that case, we fail to reject the null hypothesis. Okay. So, how we come to decision in p-value method? We compare the p-value with alpha. If p-value is less than alpha, we reject H naught. Remember, this is true for left tail, right tail or both tail test. If p-value is less than alpha, we reject H naught. If p-value is greater than alpha, we fail to reject H naught. Since our p-value is greater than alpha, we have failed to reject the null hypothesis. Step 5 is the final step of the hypothesis testing. Since we have failed to reject the null hypothesis P1 equal to P2, that means we cannot say that P1 not equal to P2. So there is not sufficient evidence to conclude that proportion of residents who support this law is different between the two cities. Okay. Since in hypothesis testing, whether you do in p-value method or in conventional method, the decision and the conclusion comes out to be same. Hope you like my video and this video is helpful to you. If you like my video, please like and subscribe for more such videos.